part and then forgot.
Shut up. Let's rewind to where I asked any of you. See how I'm still rewinding? Because I never asked. I know. I do a lot of hand gestures when I go forward. No, it's funny. Everything I do is for comedic effect. As you well know, YouTube feels I am not educating anyone, as is evidenced by the marks. So, see what I did there? Got a little gag, got a little dig in on you guys. All right. But seriously, folks, we're not supposed to be telling jokes. Seriously, folks, what do we notice here? Talk to me. What do you see? What happened? Gersa. The two lines crossed, right? What property of those lines is it that allowed for them to cross? The slope, right? Because one slope was -3/4, one slope was -2. Eventually, how long is this blue line going to go? Forever. In which direction? Both ways, right? So that blue line is going to do that, isn't it? And that red line is going to do that, isn't it? Are they ever going to cross again?
No.
Why?
Yes, they can.
Because they're straight lines. They don't bend.
Unless they go around that.
So, I'll ask you again, what are some conclusions we can draw from this system? Right. There's only one intersection in a... What kind of system is this? Right. There's only one intersection in a linear system. In a linear system possible. Right? And what is it that makes that possibility? Right. Different slopes allow for that intersection. Everybody cool? All right. It's still on the screen. Let's do the next one. Let's do some graphing. Red one. What is it? (4y) equals -2x plus 12. Y equals -1/2 x plus 3. Oh, all right. 1, 2, 3. -1/2. How long will that line go? Forever. I'm not going to shrink the page again. What about the blue one? 2y equals what? -1x plus 12? Minus 12. And what does y equal? -1/2 x minus 6. 1, 2, 3, 4, 5, 6. Down 1 over 2, down 1 over 2. What do you see? They're parallel, which means what? What, Jake? Jaden? They don't touch. Why don't they touch? They're parallel. The slopes are the same. If I go down 7 million, I'm going to go right 14 million, aren't I? And that's going to be the same thing on the red one. They're never, ever going to touch. So, linear systems have how many solutions? In this case? In this case, none. Linear systems have no solution. If what? The slopes aren't parallel. If the slopes are the same. Because the slope isn't parallel, the line is parallel, right? If the slopes are the same. And now, let's just do this, because this reminds us from our unit 2 units ago, they're parallel. Right? Everybody understand? Oakley dokley. Let's do this last one. The red one. Go. I just read an article on the history of that song. It's 50 years old now. I can't even tell you because it's naughty.
Turn off the recorder.
Let's go. What's happening here? Come on. No, you don't need to tell me in a minute. You can tell me now. What are you doing?
The 3 becomes -3 on the other side.
Why would you do that? Why wouldn't you just leave 3 there?
Oh,
3y equals -2x plus 5. Y equals -2/3 x plus 5/3, right? Why is that a pain to graph? It's a fraction. So what should I do? I could wait for the other one, or I could change the scale, right? So, either way, this one, what happens? It's an easy one. All I got to do is what? Divide by -6. So I'm going to get -4/6 x plus 10/6 equals y. That looks suspect. What should I do with it? Simplify it to -2/3 x plus 5/3. Wait a minute! Son of a bee. Well, let's graph it. 1, 2, 3, 4, 5. Why did I go up 5 dots? Because I changed the scale, right? So if I keep the same scale over here, if I make that 1, 2, 3, 1, and I make that 1, can I just count 2 and 3 now? Yep. Down, 2, right, 1, 2, 3. Agreed? Down, 2, right, 3. Excellent. Now let's do the for blue. Hey, what do you notice? How many times do those 2 lines touch? Infinity. So how many solutions are there to this system? Infinite. Nope, because every xy on both lines will work for both lines. 2 lines that are the same. And when I say the same, what do I mean? Same slope and same y-intercept will intersect how often? Intersect infinitely. Therefore, how many solutions? Infinitely. Therefore, we have how many solutions? There's infinite solutions. So, what are the only options for a linear system? Right. You can have no solutions, 1 solution, or infinite solutions. What tells us? What property of these equations or the lines tells us which of those 3 choices we have? Slopes are the first thing that will tell us 0 or 1, and then the y-intercept will tell us if it is infinite. If the slopes are the same, do we have to check the y-intercept? Yes. If the slopes are different, do we have to check the y-intercept? No, because once slopes are different, you know you're going to have a solution, right? Okay, so without solving, no substitution, no elimination, no graphing, how many solutions is A going to have? Why? Does it look like it? Or did you check it? Y equals negative x, right? And in the top one, y equals negative 1/2 x, right? Are those different slopes? Are they different slopes? Yes. So how many solutions? One. I don't even need to check. This one. 5y equals negative 3x, yes? So what does y equal? Negative 3/5 x, yeah? So let's go to the second one. Y equals negative 6 over what? 10x. Does that look a little suspect? What should I do with it? I check, first of all, I simplify. Same slope. So now what do I got to do? Check the y-intercept. So this one was the black one. What was the y-intercept there? I move the 9 over. It becomes positive. And then what? What did I do with that 5? So it's positive 9/5, right? Okay, then I check with the red one. I divided by 10, yeah? So this is plus 18 over 10. What's that? What's that? It's the same, 9/5, yeah? So what do we have? Same line, so it's infinite, yes? Now, obviously, what's this one going to be? It's going to be the 0 one, right? But how did I make it more difficult on you? I changed it from x and y to p and q. Does it even matter? Because who's in charge of this question? You are. So if you isolate q, then q is your y value, right? If you isolate p, then p is your y value. Because what are you going to find? Whichever way you isolate it, the fraction of the other one is going to be what? Once you isolate, you have the slope and the y-intercept, whichever way you go. And what are you going to notice about the two slopes? They're the same. And when you check the y-intercept, what's going to happen? They will be different. So, you could isolate q. Negative 5q equals negative 2p plus 30. Q equals 2/5 p minus 6, right? Or I isolate p. 2p equals 5q plus 30. P equals 5/2 q plus 15, right? Then I isolate q in the second one. Q's already there. Q equals 4 over 10p minus 15 over 10. That's a little suspect. 2/5 p minus 3/2, right? Right? And then I come over. So there, you see, same slope. Different y's. Amelia. When I brought that 2 over, it became negative. So now I have negative divided by a negative. And then over here, if I isolate p, then it's 4p equals 10q plus 15. P equals 10 fourths q plus 15 over 4. P equals 5 halves q plus 3 and 3 fourths. And you see same slope and different y's. So that would have 0 solutions. Right? Once again, we find what is the most important characteristic of a line? Slope. If you are doing anything with lines or the word linear in it, what is something that will probably help you? Finding the slope. Even if we go all the way back to functions and relations, when we first did graphing, weren't we finding slope? But we were calling it rate of change because it wasn't a slope. This was specific. It was meters over minutes. So it wasn't just x over y, right? But in general terms, no matter what, it's dv over iv, right? Everybody good? All right. You will need a quiz. Didn't I say we were having a quiz today? Are you sure? That seems pretty suspect to me. But okay, I will choose to believe you. It's not like I couldn't go check the video if I wanted to. All right, I choose to believe you. So let's rectify this situation. Tomorrow you will write a quiz on systems. There will be systems, and it will look very similar to this. I'll give you some systems. You will solve them. Okay? I'll throw some multiple choice on there, and I'll throw some open-endeds on there, and we'll all be good, yeah? Oh! I was vaping my coffee there. Whew. Well, that's all vaping is, sucking liquid into your lungs, which is, short for drowning. Whew. Have you guys ever heard that gag? Some guy in Sacramento, to prove how stupid the city council was, went in with like a PowerPoint and all these statistics and told them that the silent killer dihydrogen monoxide was available or was present in Sacramento. Brody's already laughing because he knows what this is. Dihydrogen monoxide. Di means two, right? So 2 hydrogens. Mono means 1. 1 oxygen. What's that? Water. And he had all these statistics like if your dog breathes in dihydrogen monoxide, your dog's going to die. Right? In 100% of drowning victims, dihydrogen monoxide was found in their systems. And he had all these things like this. And the city councilors actually, man, we better do something about this. And they had like a law against water. And somebody finally said, isn't that water? And then everyone was like, I don't know. So, yeah. And yeah, exactly. Right? Yeah, it was just to mess with them. Yeah. Oh, yeah. That's funny. All right. So, yeah, go. All right. Anyway, why did I stop? I was on a track. Oh, when I vaped my coffee, right. Tomorrow is short day, yes? Pep rally, short classes. Not early dismissal, short classes. So, that makes good sense that we'll quiz tomorrow. Yeah? And then we'll see how much time is left. The last thing in this unit is word problems. And I know how bad you guys feel about word problems. Even though once we go through it, you'll be like, oh man, why did word problems ever scare me? Okay? So what we'll do is tomorrow we'll do that quiz and we'll do that lesson, but I don't think you'll get enough practice with it. So we'll practice it on Friday, and then we'll do our review Monday, and we'll do our test sometime next week.
Okay.
Sometime after Monday, because I'm not telling you the days anymore.
Not Friday. I'm going on Friday, actually.
Where are you going?
Toronto.
Oh, I don't want any presents from Toronto, so it might be on Friday.
Can I have a present from Toronto?
You bring me a little Drake bobblehead or something.